Hello everybody, today I want to play around with C++ containers, with vector, with set, with list. This is two popular three popular containers. Also there is a map and GQ, but let's see. And there is a lot of articles about difference in performance, and I want to measure performance of vector, set and list. So let's get started. Let's make the folder containers, and here is it. I'm going to write some test code, and first thing I want to test is adding random values to container. So let me think how I can do it. I think I'll do like function, and first one is going to be v, and it's going to take parameter n, and here I'm going to do loop for 0 then n plus I. Going to add vector. Let's call it a rand. So include vector, include set, and include list. So it's going to be v. This one is going to be s. So it's for set. And let's do rand 0. I think I'll do it outside of the function L. So I'm going to measure inserting time push back. So okay. So I think I'll have function bench, and it's going to take pointer to function f, and I'm going to first f, and it takes int parameter f int 4 int equal 1 and less than, let's do 100,000 plus equal by 10,000 100. Yeah, okay, let's do 100. So let's compile it first. So I'm going to compile it with O1, O3 actually, and use C++ 14, I guess, standard. Okay, we need rand, and rand is, I believe, C stdlib. Okay. So how we supposed to measure time? And you know, the funny thing, recording is going to mess up with my measurements, so yeah, let me see. Do I have like spare CPU for recording? So I have 4 cores, and at least, let's see. Yeah, it doesn't look like I have spare CPU for measurements. It's quite high. 10%, 10%, 3%, 2%. So let me run top. So 18%, and 4 CPUs. I think I'm good. Yeah, should be good, right? 17%. I think we're good. Okay, so let's me Google plus 11 time measurement chrono. Yeah, I need this thing, hello world, right? So static clock time point start, static clock time point end, and yeah, I'm just going to copy paste this thing here, and we use fn. So, and you know, I like to order this thing alphabetically. So let's print n here, space I think, and yeah, and I also can use auto. Yeah, looks good. Alright, include chrono. Now I can bench v, bench s, and bench l. Yeah, it wasn't bad. So I'll put comma here. You know, I'll collect all this data. How I can do this thing? Right, you know, one thing what I want to do, I want to collect all this data 10 times. 0 plus g to time mean time equals some big number 7f f, so mean time equals t mean time long int. Okay, so I think where I would store all this data. I know, I'll make the map of int string, and what I will do is data n if n empty temp n temp equal plus equal not empty comma plus equal d to string min lines. Okay, so we will run bench 3 times and then print out all these results for t data. td out, t first and d second. And you know, I can do it like this. Oh darn. Okay, so now I can dump all this thing to the file. Lab insert dot comma separated values. Okay, now so I'm going to open the file, containers, insert key and draw the graph chart, lines like this, yeah. So as you can see, I think red one, let's see, B, C, D, right? First one is vector, second one is set, and last one is list. So here is it, you can see like for set it's logarithmic, right? And for vector in list it's linear. And you can see like insertion for set is kind of quite bad, like for 100,000 it takes around 50 milliseconds, 1500 microseconds, 50 milliseconds, right? So let me anyways, this is result. It looks as we expected, like vector is the fastest one, then list is slower, and you can see like set is way slower. Like this value is let's see, is about little bit more than 1 millisecond, and for set it's 49 milliseconds, like 50 times, like order of magnitude difference. Okay, so let's do another thing. We did insertion, and set has the property, the insertion. Oh, I forgot to do one thing. Let me rerun this thing, because I need to do run here, so it's going to have same results, same insertion. So let me rerun again. I'm pretty sure we will get same results, just to have correct experiment. Okay, so we get same results. So there is a spike, and I think last time I got same spike, right? Let me run again. Kind of interesting why we have spike. Okay, let me again. So I'm going to make the copy. Yeah, it's interesting. It's kind of interesting. So let's do our things. So set has, so it's little bit unfair for set, because set has property, it keeps values ordered. So let's try to keep ordered things in the vector. So instead pushing back, I want to so what I need to do, I need to find high boundary. So std what is it, boundary, I forgot. Let me search. Binary upper bound. So I need to do upper bound for a for value TMP, and then I need to do a inserter TMP algorithm. Oh, and for list, same thing actually. It's crazy, but we can do binary search in the list, and it's mostly a joke. So, but anyways, I want to show you. Let's call it keep sorted. Oh, you know, I'm going to print out the progress because I have no idea how long to wait. So if n divide by 0 by vector set list. Okay, let's go. So vector is quite fast. You know, vector is slow, and I'm pretty sure we are going to die waiting for list. So I'm going to make n like 4 n s and way better. Yeah, list is joke. Probably I need to remove it. I don't have enough patience to kill it. It's too slow. So let's do 15. Let's print every time. Okay, so let's see results in the calc. Keep sorted. Oh, there is not too much data. Anyways, yeah, you can see this is the list and all these things. It's a set, and so let me remove column C. Remove. Finish. Oh, I should remove column D. Column D, right. So B is vector and C is set, and you can see set is winning, but there is an interesting part here, and probably I'll look at this closer. So from 0 to let's do for sure it's 3000. So 3000, because at very beginning vector should give better performance than set. So I'm going to include list because it's a joke, and I will do smaller steps for till 3000. So keep sorted. Let's do vector versus set. Okay, it was less painful than with list. So, and you can see vector is blue and set is green, red, and you can see vector was winning a little bit at very beginning, and I cannot explain this thing, like it's going like this, and then it's get faster for some reason, and then again it start going like this. And actually I can see it here also. This is interesting. So what else we can do? There is article about vector and list. I mean, you can see list is more or less joke, and actually we should be fair to the list, because binary search in the list it's quite horrible. So what we can do, we can, instead of binary search, do just a search. Find if init, and here I'll have algorithm which will take int y and no int x, right, and I want to capture temp So I want to find return, I want to find then temp greater than x, greater or equal x. Okay, and I'll do same thing for vector. So now we actually have fair for list in terms of algorithm, because search for element is on instead of log n for vector, and like I don't know, n squared and cubed for list. Now we have on for vector and for list, and insertion actually for list is o1 and for vector it's on. So algorithmically list should win, right? So let's run vector versus list fair. Let's return back list. So let the vector versus list fair. So this is list, it's still slow, and this one, red one, is set. And what we can do more dots, and like theoretically list has to beat vector at some point, and let's see what we'll be able to beat. So what we can do, we can try up to 30,000, and let's do 3 points, it's too small. 6 points and 30 points, it's too much. 15 points, let's try to 15 points. It's going to be horribly slow. Let's do 3 here. You know, it's a joke. It's running, and I don't think it will ever catch up. And it's a lot of time, and to reach 100%, it's going to take even more time, because it's n squared, right? So I'm going to cancel this thing. We will not see results, but for me it's pretty obvious. Like list is never going to become faster than even vector, and set is like perfect for this sort of tasks. I was thinking about like what kind of application list can have, and I think with map you can do some fancy things. So like a caching and invalidating the cache, or like cleaning up the data, because you can cache a lot, right? And at some moment you would run out of memory, and you would need to know what kind of things you need to remove from your cache, and you kind of have to know what kind of old one, like which data you did not access, and you can have this sort of structure, right? Let me just write the code. Cache. So you can have this sort of structure like std list, right? And list is going to have like cache. What is it? What is cache? It's a map, right? And you have key and some data. So you can have key in the list, and for cache data you can have map, and like it's better to have an ordered map because it's way faster, and like you can have key and some data, right? But along with data you may have pointer into the list, so like this. So what you can do, you can have some access to data, right? Like getter, right? And it's going to return int, and inside you can do like search in the map, right? If find like by key, right? Key, and if you did not find anything, you need to so if you did find right, do things there like this. So if you did find, you just return iter second, and also iter second dot second, and also you are removing iter second dot first. You are removing things from list, and you are inserting the key, pushing back the key at the end of the list, and also modifying iterator second dot first equals l dot and -1, something like this. Like, you know, something like this. And otherwise you're calculating your data, like this is getting things from cache, and like this one is 01, this one is 01, this one is 01, this one is 01, and this one is like all this thing is 01. Here is it, like you need to calculate, you need to get the data not from cache, like real data. So you're getting real data, and basically you're doing same thing. Basically what you can do just this thing, right? You got the idea. So anyways, thank you for watching, and hopefully you like this video, and bye.